Hello everyone. Today we are going to solve the problem string duplicates removal. So it is a difficulty easy question. So the question is given a string S which may contain lowercase and uppercase characters. So our task is to remove all the duplicate characters from the given string and find the resultant string, and the order of remaining characters in the output should be same as the original string. So this is the question. So if you see the first sample input they gave, or let's take the first one for our explanation. So the first string is S is equals to G E E K S Geeks Geeks for Geeks, which is written in the upper and lower cases. For again G is capital, so again E also capital, and then E K S. So this is the first sample input, and the second one is a Happy New Year. Let us discuss the first one only, and the expected complexities are big O of n and big O of 1. So let's see first how to solve this program. So this is the first given sample input. So our core logic is to handle a scene array in which we will store if a character is seen already in our resultant string, then we will not add it. Or let us take an example which is a bar, or any, so let us take a bar example, or a who is a security watchman who need to only allow the unique persons or only one-time persons inside. So there will be a set of persons who will be at the entry. So one by one the persons will come to the watchman. So the watchman will check as he has a entry list. So if this person particular who came to him is already present in the arrived list or not. So if it is not present, so then he will be saying that you are a new person, so go inside, and then he will add his details into the book. So if next time the same person will come, then he will check in the entry list and he will be present, so he will not allow. So like that. So the same logic we will be using here. So we will use a scene array which stores only true or false at each index. So C, the size will be for this series array is 256. So as we all know, all the characters or strings, any type of characters in the alphabets or into the programming language are categorized into 256 symbols. So 256 ASCII characters or ASCII symbols are present in any language. So 256 ASCII symbols is equals to 256 scene size array. So it will be static, not dynamic size. So scene is there. Now you take a new string to store the result. So new string is equals to empty initially. So for every character from S, the given string will compute. Like now if we see in this example, it is G. So for G, we will check if it is present in the scene array or not. So it is not present. Then the output string is now is equals to G, and scene will be is equals to G. So G and G. Now what is the second character? It is 2, which is E. So E is not present in the scene array. So the output string RS is equals to G E, and scene will be is equals to G comma E. So next it is a capital E. So again it is not present in the scene. So G, E and E, and we will add it as true in the scene array. So in scene array we will be not storing this G comma E values. Instead we are going to store the true value at that particular index of the character. So at the index G we will be storing true out of all 256. At here also at index E we will be storing true. So actually this true or false value will be storing in the scene array rather than the characters. That is makes our space as a big O of one space. So next the scene will be G comma E comma capital E. So next we got we got K. So K is again not present. So G, E, capital E, K, and scene is G comma E comma E comma K. So again we got the character which is S. So S is not present. So G, E, K and S, and we will add. So let us write directly like this instead of writing every time. So the scene currently is equals to G comma E comma G comma K comma S. So now after S we have F. So again it is not present. So F, G, E, K, S, F. So we will add F, and after S we have O. So again RES is equals to G, E, K, S, F, O. So we will add O. So after that, after O we have R. So if R is present, it is not present. So result equals to G, E, K, S, F, O, R. After R we have capital G. So is capital G present in the scene array? So it is not. So G, E, E, K, K, S, F, O, R, capital G. So after this, next is a capital E. So it is already present, so no changes. Again it is capital E. So after capital E we have small e. So it is also present. So next K, it is also present. So S is also present. So there is no changes in the result. So at last the resultant string will be G, E, E, K, S, F, O, R, G. This is the output. So what is the thing we are going to do? So we use a Boolean array which stores a true or false. By default false only, of size 256. The 256 is because the number of ASCII symbols are also 256. So the new string to store the result is RES. So for every character from the string S, the given one, we check if it is present in the scene. So if it is not present, we add to the scene, we add to the result. So at last our result is computed. So very simple. So 256, we need to remember it is the number of ASCII symbols in the language English. So So we will use the same logic here. So we said we will use a scene array which is boolean type to store the true and false values. So new boolean of 256, and next we set to store. So instead of string we use string builder. So string builder is because we can add dynamically and it enhances the time and space complexity a little bit rather than the traditional string. String builder is a more optimized one. So for every character in the given string, we can get the character array of the given string using the dot to caret method, inbuilt method, which return the character array of the given string. So we check if the character C is not seen, then scene of C is equals to true. That means C is already present, and if it should be present, then we need to append the C to the output. So at last, the output type is string, not string builder. So RAS is a string builder. So to string method. So we can see the sample test case is passed and the hidden test case will be, so we can say it is passed. So now we will analyze the time and space complexities. So this space, you think it is a big O of n space, but the size of the space, which is an array, is not dynamic. It is always static, 256 only. So irrespective of the input size, the scene array size will be 256 only. So it is big O of 1 in that way. So this is also big O of 1 is normal variable. Time will be big O of n because it depending on the input size. The condition statement is big O of 1. So at last, finally, the time is the maximum possible value, which is big O of n. Space is maximum possible only, so big O of 1. So now if we compare, they are matching. So this solution is the best possible solution for this particular question. So kindly go and practice the program. The program link is given in the description. Thank you for watching. Subscribe for more videos.